Good evening, all. Week 8 class for the course of Novel Technologies for Food Processing and Shelf Life Extension. My name is Ram Kumar Desmukh. I am doing PhD at IIT Roorkee under the guidance of Professor Kirti Rajki Gaikwad. We will start within 2-3 minutes. We will wait for some time, then we will start. Meanwhile, anybody, if they want to join. Meanwhile, I'll give a little bit introduction about me. So, before joining PhD here, my I have done my bachelor's in dairy technology from College of Dairy Science and Food Technology College. Uh, it was recognized by ICAR, and then I joined for a Master of Technology in Food Science and Technology from Sambalpur University, Odisha. After doing MTech, I did join as a junior research fellow at NIPTEM Tanjavur. Formerly, it was known as IIFPT Tanjavur. There, I worked for 15 months on an Indo-UK collaborative project. Then Corona hit, and then almost for 1 year I was at home. But after that, I joined as a project assistant at IIT Roorkee from August 2021 to December under the guidance of Professor Kirtiraj K. Gaikwad. Then in 2022 January, I joined as a PhD student under him, and this has been like one and 1 year and 3 months as of now. I'm here, and in ninth cycle of May 2022, I got selected for and under PMRF, the teaching, the TA is our responsibility to take one class for 1 hour each week. So I am here uh, taking my TA teaching assistant for this course, Novel Technologies, to extend the shelf life of food product. Okay, so I think we should start. Here on the page, if you can see, this is my Google Scholar profile. This is known as a researcher profile. If you will go and if you will start your journey as a researcher or academician, you will get some publication, what you work, what you do in your lab. If you publish them, and if you will make profile, so that reports of that publication will come under your this profile, and the index, like citations, how many citations you will get for your work will be cited and counted here. So this is like your Facebook or LinkedIn profile, where you do something, and after doing something, people are looking at your profile, people are citing your papers, so that will be counted as your uh, worthiness, how much your work is getting recognized by other people working in your field. So this is like your portfolio for other people, what you are doing. So if you will do researcher, or if you join PhD, so you have to get some publication to pass your PhD. So this is the Google Scholar profile, but that is in the that is for if you have publications, but you can search papers on the Google Scholar profile. that doesn't need any profile. You can you can simply go to the Google Scholar page, and you can search whatever topic you need, and you can read your papers or your interested areas paper. So that's it for this page. Okay, so first question, mostly the question here are memory based questions. So if you remember those questions, or if you know the answers, you can write in the comment box. After some time, then I will give answer and explain why it is the right answer. So first question is here: which of the following is most acceptable and cost effective commercial method of ozone generation? So your options are: A. Electrolytic method, corona discharge method, photochemical method, and radiochemical method. So if you know answer, please comment in the chat box. Gayatri Radhakrishnan has answered B. So I'll again repeat the question. Which of the following is most acceptable and cost effective commercial method of ozone generation? So here you need to tell which method is used as a most commercial and acceptable or cost effective commercial method for ozone generation. So you can answer whether it is A. Electrolytic method, corona discharge method, and C. Photochemical method, and D. Radiochemical method. So the right answer is a B. Corona discharge method, and detailed solution is like corona discharge method is the most acceptable and cost-effective commercial method of ozone generation, as they have given. If you will go to the main class of video, you will know uh, for explanation of other methods. So please go to the class. Question number two: a silo of 1.82 meter in diameter and 20-meter high is made of mild steel sheet. Corn is stored into it up to a height of 15.24 meter. Compute the vertical pressure at the base of silo. Given the bulk density of corn is 700 kg per meter cube. Angle of the inter-grain friction 30 degrees centigrade, and coefficient of friction between grain and mild steel is 0.42. The ratio of lateral to vertical pressure is 0.33. So you need to here count what will be the vertical pressure in kilonewton per meter square. Please, if you can solve, please solve it and tell me the answer. I'll wait for 3 to 4 minutes and I will answer. This is a numerical answer. If you know the method, and so you can solve it. This is a this is a this is a this is a question of a silo, and that has stored the corn, and you need to tell the vertical pressure at the base of the silo. So you have a given different information here, that is the silo diameter, it's a silo height, and the corn store the height up to 15.24 meter. That corn density is 700 kg per meter cube. Then friction coefficient of friction point 0.42. Then the ratio of lateral to vertical pressure is 0.33. So you need to find out what will be the vertical pressure. Okay, Varuni Chandrakar is saying C. Okay, please, if you can guess, also you can guess. Okay, uh, that will be also that is your intuition. If it is right, then good. Then I will tell you the full answer or solution for this question. Okay, so detailed solution we need to know first before going to the answer. Diameter of silo has given 1.82 meter. The height of silo which is full with corn, that is 15.24 meter. Crane density has been given 700 kg per meter cube. Angle of friction is 30 degree. Okay, it is looking like 300. Okay, but it is a 30 degrees. Okay, let me uh, write it. Okay, an angle of internal friction is 30 degree. Then coefficient of wall friction is 0.42. The ratio of lateral to vertical pressure is 0.33. That is K. Then that is a hydraulic ratio, that will be R equal to D upon 4. So D is, we have a diameter of silo that is 1.82 meter. So 1.8 by 4 equal to 0.455 meter. Here your height of silo is greater than hydraulic 4 into hydraulic ratio radius. So it is a deep bin. Okay, it is a very deep and very heighted bin. It's about 20 meters. So it is very deep bin. So we need to apply the formula for lateral pressure. The lateral pressure formula, you need to remember this: P1 equal to rho gr upon mu into push bracket 1 minus e raised to power minus mu kh upon r. Then you will put all the values here, and if you will calculate, the p1 value will come 7367.5 newton meter square. Then if you will convert it into the kilonewton, it will be 7.367 kilonewton per meter square. This will be the vertical pressure. Then what, this is a lateral pressure. Then vertical will be the lateral pressure upon the ratio of the lateral to vertical pressure. That will be lateral pressure upon K. So 7.367 upon 0.33. So your answer will be 22.32 kilonewton per meter square. So your answer will be this. This kind of question will be solved only when you know the formula. So here you have given all the details about the silo and the corn and the angle also, friction also. So you need to know whether this silo is a deep or shallow bin. So here you need to know that your H is more than 4R. That is a hydraulic ratio. So it is a deep bin. Then you will apply for this formula, and you will put all the values, and you will get the vertical pressure. Then vertical pressure will be putting for the vertical pressure formula is lateral pressure upon the ratio of lateral to vertical pressure. So you will get your vertical pressure here in kilonewton per meter cube per meter square. Okay, so if you have any question, you can uh, tell me. Okay, okay, let me share screen again. Did you guys uh, hello? So did you guys get it? What I have explained to solve this question? Please answer on the comment box if you get it, or do I need to explain again? Maybe I was, if you don't see, okay, if you cannot see the presentation or slide on the screen, please let me know also. You can tell me by unmuting yourself whether any problem. Is it the voice? Is it about the slide also? Okay. So okay, so here all the details have been given. Diameter of silo, the corn starch which have been filled, which whether which up to which height it has been filled. Okay, so that has been given 15.24, that is H. Then diameter is d equal to 1.82 meter. Then grain bulk density, that is corn, that is 700 kg per meter cube. Then angle of internal friction has been given 30 degree centigrade. Coefficient of wall friction has been given mu, that is 0.42. The ratio of lateral to vertical pressure k is equal to 0.33. So we need to check which type of beam is there. Okay, so we need to check, we will check by the hydraulic ratio, that is r equal to d upon 4. So our diameter of silo is 1.82 upon 4, that is a 0.44 meter. So you need to for checking the which type of bin is here, you need to find out uh, the height of silo. Okay, your material has been filled, the height of your material filled is greater than 4 into r, that is hydraulic ratio. So here your height of silo is 15.24 meter, that is far greater than your hydraulic ratio. So it is a deep beam. First we got to know, then we will apply for the formula lateral pressure. Okay, so here what is the formula? Formula is P1 equal to rho gh rho gr upon mu. Then bracket 1 minus e raised to power minus mu kh upon r. Then you will need to put all the values and you will get P1, that is your lateral pressure. It is 7367.57 Newton meter square. So you need to convert it into kilonewton. For kilonewton you have to divided by 1000. So it is a your lateral pressure. So you need to find out what is a vertical pressure. So what for vertical pressure, the formula is lateral pressure upon k, that is a ratio of lateral to vertical pressure. That will be 7.367 upon 0.33. So that will be your vertical pressure 22.32 kilonewton per meter square. Okay, so that is your full explanation for this question. So now if you have any doubt, you can ask me. Okay, so here 22.32, which will be the answer. So answer C is a correct answer for this question. Okay, now you got it. Okay, I will tell you one thing. To solve this kind of question, okay, you must know the formula, and you must know the uh, what will be the parameters are given. Then you will just put the formula, and if it is a formula for that particular the parameter they have asked, yeah, or whether it is a pressure, height, or it is a time. So you need to put that particular formula for this question, then you can find out, because most of the time we don't remember the formula, so we don't know how to calculate the answer. So that is very important, and it will get the formula you will get by understanding the concept, by watching the videos of this course, of this lesson or this chapter. So please do watch, because if you are going to attend the examination, if you are registered for this course, so you need to know uh, the formula, then only you will be able to solve this question. Okay. So moving to the next question, which of the following options shows the correct trend in terms of their decreasing oxidation potential? So you need to tell here. You have given four options, and you need to arrange in a decreasing oxidation potential. So option A is ozone, then peroxide, then hyperchloride, then free chloride. Option B is ozone, then hyperchloride, then uh, peroxide, then free chloride. Then C is peroxide, then hyperchloride, then free chloride, then ozone. D is free chloride, free chlorine, hyperchlorides, peroxide, then ozone. Please, if you know, please answer in the comment box. Varun is saying A, ozone, peroxide, and hyperchloride, and free chlorine. Anybody? And these questions, these videos, and the PPTs will be available on the link. I think you might get the link with in the email address. Okay, so you can watch it later also, if your any friend missed that classes, so you can ask. Okay, I'll tell you the answer. Okay, first you tell me whether your options are correct. Then I will tell you what will be the answer. Jadeswaran is saying B. Is that B, sir? I will tell you, Jadeswaran. Anybody else? Gayatri Radhakrishnan is saying B option. Okay, here you don't need to be very precisely correct. If you feel like if you know one or two options, you can answer, you can answer the correct here. But if whether you don't know here also, you can at least guess, because sometimes when we prepare for exam, we are sitting on the exam. Okay, sometimes you don't know the answer exactly, but you go for the guessing. So if you can think in the right direction, so you will get the right answer also. Okay, so let's see what is the. So answer A is the correct answer. The ozone has a maximum, then peroxide, then hyperchloride, then free chlorine. So here we have given the oxidation potential in decreasing order. Ozone has a 208, then peroxide 178, hyperchloride is 148, then free chlorine has 136. So those who have given answer A, they are correct for this question. Question 4. For a particular mass of grain stored in a bean, the angle of internal friction of grain is a 40 degree centigrade. The ratio of normal pressure to the applied pressure within the bean is. You need to find out the what is the ratio of normal pressure to the applied pressure within the bean. So please solve it. If you know, then I will tell you the answer. What will be the answer? Here you just need to. I think if you know the formula, you will solve it within 1 or 2 minutes. Okay, please solve it. Then I will tell you what will be the answer. Okay, Varuni is saying B. Okay, I'll tell you the solution. Then we will get to know what will be the answer. Anybody else? Okay, let's go to the solution. Okay, so answer. So angle of internal friction has been given theta equal to 40 degrees centigrade. So ratio of internal to lateral to vertical pressure K equal to that is the ratio of normal pressure to the applied pressure, and that is K equal to 1 minus sine theta upon 1 plus sine theta. So here you know sine and theta, you know that internal friction is a 40 degree centigrade. So 1 minus sine 40, then 1 plus sine 40. Then if you will solve this formula or this equation, you will get answer 0.21. So that will be the your correct answer. So they, like you see, very very small formula you need to remember here. Then you can put the just one formula and you put value and you will know what will be the correct answer here. So like this, you need to remember some formula to solve the question. Then you will get to know what will be the correct answer. So for this question, the A 0.21 to 0.22 is a correct answer. Here, match the function of biological laws given in column 1 with the similar function operated by eNose component in the column 2. Okay, here biological nose, what we have in our human system, like we have nose, we have mouth, where, from where with we use to inhale the aroma or some whether it smell, whether bad smell or good smell comes. Okay, so we need to match. Column 1 has been given the biological laws functions like inhaling, mucus, olfactory, epithelium, nervous impulses, and column 2 has been given by the eNose. That is eNose means that is a electronic component that works like the our biological nose. Like they have given filter, circulatory, and neural network, pump, sensor. So please, if you can match from column 1 to column 2, then you can tell me the answer. And here you can use your common sense also if you don't know, and you can know what will the answer. So I'll waiting in the comment box if you can answer. Okay, so inhaling, what will be the column 2 function? Filter, circulatory and neural network, pump, sensor. So Helena is saying uh, C. Okay, anyone? Okay, Varuni is saying D. Anyone else? Gayatri is saying C. Okay. Jadeswaran saying D. Okay. Okay, let's see what will be the answer here. Option C is the correct answer. So inhaling is a pump. Okay, so in our biological system, what we inhale that works, that is called pump in the e nose, and the two mucus, that is filter, and three olfactory epithelium, that is sensor, and nervous impulse, that will be circulatory and neural network. So if you have given that inhaling, if you know one or two answer, you will tell the correct answer here. So by this you can eliminate the wrong answer, and you can predict what will be the correct answer here. So like this you can do the what your approach to give the answer. E-nose operate like a human nose by containing a large number of sensors. Inhaling uh, work as a pump in the e-nose, mucus as a filter, olfactory epithelium as sensor, and nerve impulse as a circulatory and neutral network. Ear is improved with the increase in the operating pressure and fluid temperature. So that works upon the different operating pressure and the fluid temperature to evaluate the different kind of smell or different kind of fragrance in multinational companies like food or pharmaceutical. So they use e-nose to detect what kind of component is present in the any material, any substances. So that is called e-nose. Uh, uh, Further, in the question 6, in hyperspectral imaging equipment, filling the blanks allow only specific wavelength corresponding to a particular image to be captured by camera. So that is a memory based question. So if you have gone through this class, so you can answer it. So options are light source, imagining optics, imagining charge coupled device, and tunable filters. So what will be the answer? Please let me know in the comment box. Okay, yeah, this one is saying D. Gayatri is saying D. Okay, then the Varuni is also saying D. Okay, let's see what is the correct answer for this. So you all are correct. In hyperspectral imaging equipment, the tunable filter allows only specific wavelength corresponding to a particular image to be captured by the camera. You know that allows. Okay, so what will be the allow? Light source cannot allow. Imagining optics cannot allow. The filter that will filter the specific wavelength. So by this you can uh, check the word meaning. So what will be the what can be the filter for this specific wavelength? So that will be tunable filters. By this you can tell what will be the correct answer. So light source here it eliminates the sample. White light can be used for NIR and visible data collection. Specific wavelength can be selected by using filters here if it given. Imaging optics collect sample reflectance and illumination wavelength. Tunable filters, that is a component allows only specific wavelength corresponding to a particular image to be captured by the camera. An imaging charge coupled device. It records the intensities of an individual pixel for each wavelength in the data collection range. So here you have given all the explanation for each term which has been used in the hyperspectral imaging equipment. So to the you can go and memorize, or you can read what is a function of different terms here given. So going to the question 7, which of the among which among the following step reduces the dimensionality of the measurement space in Enos analysis? So here again we have a Enos question. So you need to tell which steps reduce the dimensionality of the measurement step in Enos. That is a pre-processing, B is a feature extraction, C is a classification, and D is a decision making. So please answer in the comment box. Okay, that is Gayatri is saying B, feature extraction. Uh, please, please answer whatever you think. Maruni is saying A, pre-processing. Jadeswaran is saying classification. Keshav Batra is saying B. Okay, so let's see what is the correct answer. There are four sequential steps in the image analysis, such as pre-processing, feature extraction, classification, decision making. The feature extraction steps reduces the dimensionality of the measurement space and extract useful information by pattern recognition. So your answer B is correct answer. So those who have given the answer B is the correct answer. Feature extraction. So they reduces the dimensionality of the measurement space and extract. Okay. Then question 8, which of the among following option is showing the correct classification of spoilage according to the level of CO2? So low level spoilage, that is a point 0.8, 0.08 to 1%, and B is a hot spot 2.0 to 3.0. C is a serious spoilage, uh, uh, more than 2.0%, and large low level spoilage, that is zero point 0.8 to 1%. Please, if you know the answer, please write in the comment box. Then I will explain what will be the correct answer. So most of the questions are memory based questions. So if you have attended the classes in a video lecture by the instructor, course instructor, so you can know the answer, and you can get. But if you still don't know, you can at least select can be the correct answer here. Then I will tell you what will be the correct answer for this question. Yeah, this one is saying B or C. Okay, Varun is saying serious spoilage, C, more than 2%. Anybody? Okay, so answer A, the low level spoilage is 0.08 to 1%. 0.1% is the correct answer. So CO2 levels indicated spoilage as a low level spoilage, that is a 0.08 to 1.1%. Serious spoilage is a 2% or higher than 2%, and hot spot is a 5 to 7%. So your answer, low level spoilage, A is the correct answer. Question 9. This is also a numerical question. 2 tons of grain stored in a bin is cooled by aeration uh, with ambient air at a 30 degrees centigrade at a volumetric flow rate of 0.22 meter cube per minute ton. The specific volume of air at 30 degrees centigrade is 0.9391 meter cube per kg, and the specific heat of grain and air are 1.67 and 1.0 kg per kilo per Kelvin respectively. Calculate the time required for cooling the grain in the bean. So you need to find out what is the time to cool the grain in the bean. Okay, so here detailed solution have been given. The weight of the grain, that is a 2000 kg or 2 ton. The volumetric flow rate is a 0.22 meter cube per minute ton. Uh, then specific volume of air point 9 point uh, 0.91. Then specific heat of the grain, that is 1.67, and specific heat of air, that is 1.0 kilojoule. So mass flow rate of air you need to find out, that is a volumetric flow rate of air upon specific volume of air. So 0.22 upon 0.91, so that will be 0.24 kg per minute. So time required for cooling, that is a mg, and specific heat of grain, then your upon the weight of the grain, then specific heat of air. So 2 equal to 1.67 equal to 1000 upon 0.24 into 1. So that will be 13,916 minute. So in hour, if you will convert it, or you will divide by 60, so it will come to 31.94 hours. So by this you can calculate how much time it will take to cool the air. So your correct answer is D, 231.8 to 232 hours. Okay, so this is a very tough question. If you can remember the formula, you will able to solve it. But I think uh, there will be other questions in the option, so you can solve this. But if you want to solve this, because this is related to grains aeration problem, that will be like cooling or heating the grains inside the bean. So what time it will take? So this question comes when you in the commercial silo that works in storage of grains in big plants. So question 10th, condition of the cell membrane of stored sheet is measured by. So this is a memory based question. So you need to tell the condition of cell membrane of stored sheet is measured by fat acidity value, B is a headspace condensation, C is electrical conductivity, and D is a seed germination. So please tell me your answer in the comment box. Okay, you're asking to show me the question 9 again. Okay, so 2 ton of grain is stored in a bin, is cooled by the aeration with ambient air 30 degrees centigrade at a volumetric flow rate of 0.22 meter cube per minute. per ton. The specific volume of air is air at 30 degrees centigrade is a 0.91 meter cube per kg. The specific heat of grain and air are 1.6 and 1.0 kilojoule per kg per Kelvin respectively. Then calculate time required in hour for the cooling the grain in the bean. So this is the question of question 9, and this is the solution. You will get the PPT. Okay, don't worry for that. Before, please answer in the comment box if you know the question number 10th answer. Condition of the cell membrane of stored seed. That you need to that if you have stored any seed in the cell or silo, so you how do you tell what is the condition of cell membrane of seeds? So you need to tell here whether it will be the fat acidity value, head space condensation, or electrical conductivity or seed germination. So Jadeswaran is saying C, electrical conductivity, and Varun is saying A, fat acidity value. Okay, anybody else? Okay, so answer is a C, electrical conductivity. So detailed solution is a fat acidity value is a measure of the chemical changes occurring within the deteriorating seeds. So fat acidity value uh, is not the correct answer. Electrical conductivity is a measure of the condition of cell membrane of the seed. Head space condensation can also be monitored to detect the grain spoilage. Sprouted grain also indicate the poor circulation in the bean, and leaking roofs are and often associated with the development of upper bridge across the bean. So your correct answer is a electrical conductivity. If there will be conductivity, so the cell membrane will be the cell is in a good condition. So in the stored seed, the condition of cell membrane can be measured by the electrical conductivity. So correct answer is a C. For question 11th, the for aeration cooling, the flow of air rate, the rate of airflow is required. So you need to tell answer here whether it is 1 to 5, B 5 to 10, C zero point 0.5 to 1, or D 10 to 20. For aeration cooling, the the rate of airflow is required. The airflow rate, that is a liter per second per ton, like 1 to 5 liter per second per ton, or 5 to 10, or whether zero point 0.5 to 1, or is it 10 to 20. Please write your answer in the comment box. Okay, Varun is saying 5 to 10 liter per second per ton. Anybody? Okay, so your answer is 1 to 5, that is A. 1 to 5 liter per second per ton, that is a flow rate, air flow rate required for cooling aeration. So aeration can have a three main uses. Aeration maintenance, that is a zero point 0.5 to 1 liter per second per ton airflow, using aeration to protect grain quality and prevent the temperature increases. Aeration cooling, that is 1 to 5 liter per second per ton airflow, using aeration to rapidly cool grain to prevent the quality and limit insect activity. Then aeration drying, that is a 5 to 20 liter per second per ton airflow, using aeration to remove the moisture from the grain. So there are different airflow to for different treatment to the stored bean in the silo or big beans. Question 12: which among the following is a chemometric classification as well as regression analysis applied for the hyperspectral image analysis? So your options are A, artificial neural network; support vector machine; C, individual component analysis; and D, convolutional neural network. So please, if you know the answer, please write in the comment box. Okay, so let me tell you the answer. So support vector machine will be the correct answer. So artificial neural network and support vector machine are a regression analysis used in the hyperspectral analysis image analysis. Classification method of chemometric include principal component analysis, individual component analysis, k-mean cluster analysis, genetic algorithm, convolution neural network, that is a CNN, support vector machine, then partial least square discrimination analysis. So your answer B is a that is a correct answer, which among as well as regression analysis. So chemometric classification as well as regression analysis. So your answer will be the support vector machine. That will correct answer. Question 13: for an airflow rate of 2 meter per cube per minute, the linear air velocity in the intergranular space in a circular storage bin having 2 meter diameter and zero point 0.4 void fraction will be. So what is the uh, linear air velocity? You need to tell here. Please, if you know solution, please let me know in the comment box. Okay, so without I think wasting time. So detailed solution here we have given the bin diameter is 2 meter, void friction, that is epsilon, that is zero point 0.4. The volumetric airflow is point 2 meter per cube per minute. So if you will convert into the second meter cube per second, so that will be 0.3033 meter per second. So area of the circular bin is pi upon 4 into diameter square. So pi upon 4 into 2 upon 2 raised to 2, that will be 3.4 meter square. So that will be the interstitial interstitial velocity, that is superficial velocity upon wide frictional. Then so your volumetric airflow rate and the volumetric airflow rate, area of the circular bin upon wide friction. We have given all the answer that volumetric airflow rate 0.033, that area of the circular bin that we have given 3.14, then we have a wide friction, that is epsilon, that is zero point 0.4. So if you will solve this equation, you will get 0.02 meter per second, that is the velocity of the air. in the bean. So option D is the correct answer. That is 0.026 meter per second. So we have, I think, this is a second last question. Which of the among following is not a common moisture proofing material for the storing of grains? So that is options are aluminum foil, asphalt, foam, polystyrene, polyethylene. So please, if you know the answer, please write in the comment box. Which among the following is not a common moisture proofing material for storing of grains? So you need to tell here which is not a common proofing material for grains. So Varun is saying D, Karupia saying B. Okay, anyone else? Jadeswaran saying B. Okay, so let's see what is the correct answer. So, foam polystyrene is not a common moisture proofing material for storing of grains. Three most commonly used moisture proofing materials are polyethylene, asphalt, and aluminum foil. For foam polystyrene and glass wools are used as an insulating material in the grain storage system. So it is not a moisture proofing because the moisture can be passed through the foam polystyrene or glass wool. They work as a insulating material between the layers like outer layer or inner layer, so that heat cannot be transferred from one from inside to outside or outside to inside. So the option C is the correct answer. The phenomena that moisture moves in the same direction as heat flow is known as moisture migration, thermo-moisture conductivity, thermo-moisture diffusivity, or none of the above. Please let me know if you know the answer in the comment box. The phenomena that moisture moves in the same direction as heat means moisture and heat is flows in the same direction. So what that phenomena is called? So moisture migration, B is thermo moisture conductivity, C is thermo moisture diffusivity, and none of the above. So Varun is saying C, thermo moisture diffusivity. Anybody else? Jadeswaran is saying thermo moisture conductivity. Okay. Anybody? Okay, so thermo moisture conductivity is the correct answer. The phenomena that moisture moves in the same direction as a heat flow is called thermo moisture conductivity. So answer is thermo moisture conductivity. Uh, Question 16. The moisture accumulation during summer due to moisture migration will be expected at the uh, which place of the bean? Lower portion, upper portion, near the wall, near the center. Okay, so you can think of yourself and use some uh, like if you have a bean, okay, silo. So in the summer season, the moisture accumulate will be due to moisture migration will be happened at which portion of the bin? Lower, upper, near the walls, or near the center? Please let me know the answer in the comment box. Please, please. This is, I think, you can tell this question the moisture accumulation. Suppose you have a silo and During summer, the moisture accumulation due to moisture migration will be expected at the which portion of the bin? Lower portion, upper portion, near the wall, near the center. Please answer. Okay. Anyway, the Varun is saying C. Jayavardhan is saying B. Jadeswaran is saying upper portion. Okay. Let's see. We will if it is if you are correct. Okay. So it is saying the moisture migration will be in the lower portion. During summer, the air takes off the moisture from the grains and moves upward near the wall of the bin after being heated by the high temperature of the surrounding. The air then moves downward through the grains at the center of the bin from the both side of the wall. So the bottom of the bins become moisture accumulation zone during the winter. So the reverse phenomena occurs. So here A lower portion is the correct answer. Moisture accumulation zone. And during in winter the reverse phenomena happens. Okay. So in the summer season the they collect it the migration that moisture migrate to the upward but it collected in the lower portion of the bin. So correct answer is the A lower portion. Okay. So I think we have ended today's class. So if you have any doubt, you can ask me today, or you have my mail ID on the screen here. You can mail me on the mail ID. You can ask me whatever your confusion or your question is there, whether it related to this class or whether you want to ask about the research also. You want to continue because if you are attending the class you might related to the food science or food technology and you want to pursue higher study or whether you are doing job any kind of I will be happy to help you guys. Thank you for attending the class and thank you for your patience and listening the class. We will join next class and sorry for the last week because of some network issue wi-fi was not working in our campus, so I was late to upload the videos and classes on the internet. Okay, so sorry, but I will do it by tonight itself because now wi-fi is working. So thank you all. Now you can leave the classes. Thank you all.